Hello there and welcome to this video series on control systems. Before we go into the video, we'll do a quick recap. System is a collection of components and or subsystems so arranged as to serve a purpose. Systems as well as subsystems within them may have a purpose and a control variable and a manipulated variable of their own. After watching this video, you'll be able to understand what is a block diagram and perhaps be able to draw block diagrams for a few systems and specify what we mean by open loop control and specify what we mean by closed loop control. With that, let us see the familiar example of a ceiling fan, and once again recollect that when you turn the regulator knob, the speed of the fan changes. In the controls language, we say regulator sets the desired speed, whereas it's actually a human being that sets the desired speed. Okay. This the regulator does by sending current to the fan. The more the current, the more will be the speed of the fan. We saw that the overall block diagram of the fan control is shown here. You have a regulator block and a ceiling fan block. The regulator receives speed setting from the user. It changes the manipulated variable depending on the speed setting, and the ceiling fan runs at a speed corresponding to each current and does each speed setting. Now let us further say that the regulator is set to a position 1. And further, let us say that this corresponds to 100 RPM. Now the fan keeps running at 100 RPM unless, what is this unless? We'll see in the next slide. Unless there is a disturbance. Now let us see what this disturbance is. Now let us say a strong gust comes into the room, strong wind comes into the room and hits the fan. When it hits the fan, the speed of the fan changes. Either it will accelerate the fan or it will decelerate the fan. So the speed of the fan changes. To look a bit more deeper into the problem, we'll ask the question, will the speed of the fan change when the gust hits it? Yes, it does, even when the speed setting does not change. And this is happening because changes in the controlled speed are not detected by the regulator. In fact, if the gust is violent enough, it may even twist the blades of the fan this way. If it happens, of course, no controller can do anything about it. The fan will get twisted and may turn if the bearings are still fine. To quickly sum up what we have seen so far, we will say that if the actual speed is not measured and the changes in speed occur each time the disturbance hits the system is said to be in open loop control. So the fan and the regulator, we have seen the domestic fan and the regulator, they are said to run in open loop control. We'll see why we call it open loop in a minute. And this we do by considering a closed loop control system. We'll consider the same refrigerator that we have seen earlier, but the situation now is different. The difference is that there is a thermocouple to measure the temperature inside the fridge. The output of the thermocouple is given to the thermostat. So let us say at each second, 1 second interval, the thermocouple measures the temperature and gives it back to the thermostat. Thermostat on its own will decide what to do next and issue a command signal, refrigerant that is circulated. We'll try to see it in the form of a block diagram. We'll try to see that in the form of a block diagram. This is the block diagram of the open loop refrigerator. We have seen that such a refrigerator will not be sold because the thermostat setting does not help when a disturbance hits it. The disturbance may hit in the form of more loading on the refrigerator or the refrigerator door opening. the disturbance we see is opening of the door. Let us say each time this disturbance occurs, the control temperature changes a little. If the thermostat doesn't detect this change, the temperature reaches equilibrium after a long time. But see what happens when the temperature is measured. Okay, but this time around, as we said, the temperature is measured and is given back to the thermostat, and this red path is what we call a feedback path. The thermostat will change the refrigerant circulation to bring back the equilibrium based on the controlled variable. So even when disturbances occur as shown over here, this feedback loop kicks in after a specified amount of time, let us say 1 second. So the disturbance may be occurring in time, whatever time, and the feedback path is measuring at 1 second, or in some situations the speed of this loop is sufficiently large, maybe after every 5 milliseconds. In some DC motors, this is done, the loop runs at every 5 milliseconds. That is very fast, about 200 times in a second. But in typical domestic refrigerators, this feedback path maybe can be run after every 1 second. So it will keep on checking the temperature at 1 second intervals. And if there is a change in the temperature from the required temperature, the thermostat will make adjustment. That is, thermostat takes a required temperature and a measured temperature, changes the manipulated variable to bring back the temperature inside the fridge to equilibrium. To summarize, we will say that if the controlled variable is not measured, the system is called open loop system. If the controlled variable is measured and fed back, the system is called closed loop system. Closed loop systems are also called feedback systems. That's all we have for now. Have a great day.